Hey guys, so today you and I are going to talk about architecture. So let's get into it. So the question in question was, hi Frederick, what are your main considerations when weighing up pros and cons when choosing an architecture? Or don't you have a general one that is usually, and is it usually a case by case kind of thing? No, I usually have actually. I have a yes. Well, I'm going to use the term silver bullet, or like I have exactly one strategy for how to deal with architectural designs. That if we're talking about like a really macro level, the details will always differ because uh, there is no one architecture that will always work. There are some proven ones that work for different types of archetypes of projects that I go to for a lot of the different systems that I've built. But when it comes to at a high level, my requirements are always the same. Number one, the first thing I prioritize above all else is business impact. That's number one. Number two is source code architecture. And number three is performance. So let's break those down a little bit. The reason why I argue that that is the order is because the first thing, business impact. The reason why I need to know what type of business impact this system will have and what type of basic like where would this be positioned within the ecosystem or within the company, like what significance does it have and what type of requirements does it have, is because that tells me what type of people I will need to deliver this. I can go as far as to say that it is the most significant question that anybody can ask when you start designing a system. What type of system are you dealing with? How is it going to impact the business? Because if you have a really low impact system, you don't need to have top performers for that. But in some cases, you find that you have systems that are, as I like to say, owned by the wrong people. And that thing is the biggest killer to IT there is. If you have the wrong developers and the wrong on a project, it doesn't matter how important it is. It doesn't matter how critical it is to your business because you have the wrong people. I've made analogies to race cars. You can hire the world's best Formula One driver, and that won't matter for shit if you have incompetent engineers who build a really shitty car. Same deal here. Doesn't matter how if it's the crown jewel of your company, that's the first thing I need to know, because I need to know what type of people I need to get in order to deliver this thing and then keep it deliverable. And something that I've always argued for, which is not the norm, I'm very sorry to say, in most companies, is that you consider the sort of product that you're dealing with before you hire people. Because, as I've said before, most IT companies, practically all of them, view software developers as a unit of a worker. And that is the biggest mental mistake people can make, in my opinion. Software developers are exactly in this regard the same thing as football players or sports people or something like that. It's down to talent. If you get 3 software developers lined up, they will all be at different skill levels. They will have pros and cons, like it's players basically. And you need the people. You need to know what type of people you need for the system, because as I've said, nothing else is going to matter. You can have the best microservices, dry, hyper performant architecture. Like, it doesn't matter. Everything else is secondary if you do not have the people necessary to meet the requirements of the system. That's why it's number one. Number two is source code architecture. The reason why I care about source code architecture is because this falls into something I call engineering politics. And basically what I call engineering politics is that I argue that quite a lot in terms of how things are orchestrated and ownership and things like that within software development, especially in larger companies with a lot of teams, comes down to who owns the code, who is able to change the code. Because if you have a model where you have one specific system that is, as I said, very highly critical or some sort, and it's outside of reach for some other teams, well, then it's very similar to having 2 engines. If one engine is really, really fast and the other engine is really, really slow, it doesn't matter because they're both going to have to be capped at the slower engine. And that's why source code architecture is extremely important. If I know that I have some shared libraries or have some type of structure that will impact how fast everybody can move as a unit, I have to account for that. And source code is the best way to do that. Because if, as I said, if you do the classic one is that, oh, we split your responsibilities based on business, then you're gonna, as I said, that's how it usually happens. You have some team who has like 100 projects and they have that one system that everybody else depends on, and they don't have time to fix it, which means that they have to allocate things that goes on their backlog, which delays other people. And so when I make a investment into architecture, it doesn't matter which one it is, the first thing I always very, very carefully consider is, how will I structure the repositories with all the different source files? I'm not even talking the logic now, I'm just talking who has access to these files. Can I create an environment where we have a workflow where we have some shared libraries and we have some stuff that is specific? How do I slice this pie so that I know for a fact that at no point will someone be blocked by somebody else who doesn't have time or things like that? And I also have to make sure that depending on the type, as I said on number one, the business impact this is going to have, I have to make sure that I structure the product in such a way that you can continue building it. Because I don't want people to do the thing that usually happens, which is that they start with this little idea of, oh, we're going to just create this sort of system, right? And then it grows too big, and all of a sudden you have a really, really horrendous microservices architecture that never makes any sense to anybody, where you can't ship anything, or you have a spider web, but like you go in the other extreme, you have a monolith with a million different dependencies, and nobody is responsible for anything, and nobody can figure out what anything does, and everything takes a million years. All these things, I argue, comes down to these two things. Basically, if you have people who are good enough, and if you know how to structure your source code over time, or structure your projects so that they can grow basically indefinitely. These are the two, in my opinion at the very least, the two most impactful things on any software project. The way that people that you have working on the source code, and the way that they treat their source code, and like how well they take care of like the ownership of the different types of like the various systems and so forth. These are the things that have, at least in my opinion, the most impact. Third and lastly, performance. Now, performance is last only because, as I said, the other two, like, it doesn't matter if you quote unquote need a high performance system. I've said that to 100 managers who come to me and say, oh, we needed to do this and that, and I go, yeah, sure, but you don't have the people. And they go, well, but surely we need to be able to do this and that. Yeah, we can, but you don't have the people. It's, as I try to, and it's another analogy. It's like you're telling me that you want to have a racehorse that can finish the race in first place, but what you have is a donkey. Yeah, it doesn't matter what you want. It's completely irrelevant how you feel, how frustrated, how angry you are. You have the wrong thing to achieve this goal. You don't have it. And so what can we do? Well, we can shuffle things like that. That's when we get into the details of all this. But the performance thing, that is important. And that's why I always say that's the last thing. The first two things are more important, but performance will matter. And the way I think about performance is basically, as I said, do I know for a fact that this system is going to be able to handle the sort of workload that we're dealing with? Because that impacts my architecture. Usually, if it's like a standard project, we're talking about basic CRUD application or something like that, performance isn't all that important. But in many cases, you have situations where you might have to have a certain, like the performance will matter, because some, as I've said before, guys, the worst thing I know is when I see someone who's gonna, like, the business requirement is literally, let's build an application that's going to be used by 3 people, and the tech lead, the first thing that dude does is say, we're going to go with a full clean architecture with at least 4 microservices to start off with, just in case we need to do like scaling for various parts of the system. And I go, you have 3 users and you're designing a system that might, just might, never have more than 3 users. Perhaps, as I said with the source code thing, perhaps you should structure your code so that when you need to split it into microservices, it's easy to do so. But maybe creating a multi-region setup with multiple microservices, Kubernetes, etc., for 3 people is a little bit much, and on a version 1.0 of an MVP. So what I want you to take away from this is that the 3 things I always go with in every single discussion whenever I'm designing a system is: number 1, business impact. I need to know what type of system we're dealing with. How critical is it? What type of skill level of developer am I going to need in order to make this thing happen? If you have a small little CRUD application somewhere that does something arbitrary that isn't all that super difficult, then you can have junior level software developers working on that thing, no problem. If it's one of the core systems of your business, you want the top-notch developers on that thing. You want to centralize talent as much as possible for these sorts of core systems. That's what I always argue. The people who have the highest level skill should ideally almost always work on the most critical parts of your business and all the systems. Don't think about it in any other way. It's like the most important system, best people on it, as much as humanly possible. Second thing is source code architecture. Make sure that the source code is accessible, that anybody can change it if they need to, if they depend on the thing or something like that. If you create a shitty source code architecture, your system will get legacy much quicker, and you're going to be in a dependency situation where external dependency becomes a problem, where some teams may not have the same capacity, and if you've locked everybody down into this mindset that, oh no, that's their code, we can't change it, well, then you just have to sit and wait. The ideal situation for you is to make sure that as much of the code as possible that you have to depend on is within your control. And maybe you don't own that code, but you sure as hell should be able to change it and train your software developers, and the entire architecture of your system should be oriented around being able to work all the time without delays. That is more important than practically anything else. Third and lastly, performance. Make sure that if you have some things that are very heavy or things like that, that you account for that. It's very easy, and it happens all the time, guys. You start with a simple system, it goes into something super advanced, or you mistake, you don't foresee things and so forth. But as I said, don't make it more complicated than it has to be. Be aware of if it's on day 1 you have something that is going to have like 1 million users. Yeah, you have to account for that. But don't get ahead of yourself. If you have 3 users, or you don't have a lot of workloads or something heavy like that, don't design a super system. I promise you, if you do the first 2 things right, you can scale into harder requirements on performance and things like that. But just be careful. That's all I'm saying. So, yeah, that's pretty much it. Have a great day.